All right, so now we're moving on to alpha carbon chemistry. Let's take a look at what an alpha carbon is here and what we're talking about. So this might be a little bit confusing based on what we've previously learned. So for example, there's a haloalkane, and a thing that we did with haloalkanes were E2 eliminations, where we would call this hydrogen the beta hydrogen, right? Would then imply that this is the beta carbon and that this is the alpha carbon. What we're talking about now in alpha carbon chemistry is carbonyls. So C double bonds O, and then the alpha position is actually right over here, and then the beta position is right over there, right? And same thing on the other side. So what you'll notice is that the alpha carbon is not what's directly attached to the carbonyl. And so then these hydrogens right here, those would be the alpha hydrogens. And then obviously you see the alpha carbon. So a little bit different design than what we previously learned, but shouldn't be too complex. In terms of why is alpha carbon chemistry important, let's take a look at some properties. So here we have pentane, and then these hydrogens have a pKa of approximately 45. And so remember that pKa, the lower the value, the more acidic it is. And 45 is a huge number because it's logarithmic. And so these protons are basically not acidic whatsoever. When we talk about something like aldehydes or ketones, they are much more acidic with pKa's around 17 and 20, right? So that's much more acidic, right? Remember, this is logarithmic, so the difference between 17 and 20 is about 1,000 times, and then 17 and 45, that's like 28 zeros. So overall, they're more acidic, which allows us to deprotonate them. So for example, if we have this carbonyl and then we have a base come in, we can deprotonate this proton and place that negative charge on the carbon. The reason that they are more acidic is because the conjugate base is resonance stabilized, right? We can move this negative charge up onto this oxygen. And so now this negative charge isn't all on one carbon, it's more spread out, it's resonance stabilized. And we'll see how this acidic property allows us to use it to make new compounds and do cool chemistry.